Hi, everyone. Thanks for being with us today for our Safety and Health Magazine webcast, sponsored by Protective Industrial Products. We are going to let everyone just settle in for just a minute and we'll start the presentation shortly. Thank you. Once again, we thank you all for being here today for our Safety and Health Magazine webcast. We will begin the presentation shortly. Well, a formal hello to everyone and welcome to today's Safety and Health Magazine webcast Critical Shifts, Breakthrough Advancements, and Industry Misconceptions of Hand and Arm Protection, sponsored by Protective Industrial Products. My name is Barry Botino. I'm an associate editor at Safety and Health and a co host of our On the Safe Side podcast. I'll be a moderator for today's event. Before we get started, I'd like to share a few housekeeping items with you all. First, the views of today's speakers and organization are their own, and they do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. We'll conduct a Q&A session with our speakers after today's event. If you have a question at any time, just click on that Q&A button located at the bottom of your screen, type in your question, and tap the send button. After this presentation, you'll also be asked to complete a brief evaluation survey, but I'll tell you more about that a little bit later. Finally, this webcast will be archived. If you want to view this presentation or any of our past webcasts, please go to safetyandhealthmagazine.com/events. You may also receive a link in our post-event email. Now let's introduce our speakers. Joining us today are Michelle Glukowski and Ben Julian. Michelle is a product sales manager at PIP Global Safety and has more than 30 years of experience in hand and arm protection. She is QSSP certified and has a high level of expertise regarding materials, product applications, and industry regulations. Ben serves as PIP Global Safety's product marketing manager, and he has built a strong knowledge of industry specific risks, hazards, and needs over nearly a decade long safety career. He is able to develop tailored solutions that fit an end user's specific requirements. With that, we welcome you, Ben, and please take it away.
Alrighty. Thanks for that intro, Barry, and just want to say good afternoon to everyone for joining us. I always like to start with a huge thank you for your time. We know everyone's busy with their day-to-day responsibilities, but really, we hope that you can take something valuable away from what we're going to discuss today. We've got some really good stuff in the hand and arm world going on, so let's get right into it. All right, so for the next 30 or 40 minutes or so, we're going to discuss a few things about hand and arm protection, but really what the goal of today is to give you transparent information, information about what's going on in the hand and arm protection world, right? Your job as a safety professional, it's not solely focused around PPE, and that's really where we can come in and help you. So we want to share some insights with you on how some new innovations, some existing technologies, can help you. And hopefully we can link those things to maybe some pain points that you might be experiencing with your workforce as it relates to PPE. So you see today's agenda there. We'll start with some basic things like glove evolution and standards, materials, and what each addresses in the world of safety. And then after that, what's probably most exciting part of this webinar is around trends. The trends, the pain points, and really what's driving those new products and innovations to market. And then as we move forward at the end, we'll wrap it up with Michelle. She's going to talk a little bit about useful life criteria and how that evaluation process can help balance that protection, the performance levels, and really the value that you're expected to manage regarding the PPE that you spec in and implement. So again, we'll start here with a little build-up, right? Really want to cover how far hand protection has come since the pre and early 1900s, all the way back. You see there starting from the left. No, it wasn't that engineered material and yarn that we know today, and that started the evolution of hand protection. It was actually animal hide, which was used a long, long time ago to craft the first glove. You can see a picture of it there. Yes, it was a fashion statement back then, just as much as it was a glove used for protection. But like everything else, as time progressed, we saw evolution. We saw the first leather gloves made for miners and blacksmiths, which eventually turned to mass-produced cottons and leathers. They were made faster, they were made cheaper, and they were used for both occupational use and even use during World War II. But as we got a little closer, we got into the 80s and 90s. That's when ANSI formally introduced cut, puncture, and abrasion testing, which really was huge. That's what helped us better quantify how gloves could better protect workers facing specific risks in those specific applications, which was huge because it was now no longer such a trial and error game to protect workers' hands, right? It wasn't a one glove does all type of thing anymore, and it really helped us protect workers more. Um, Also during that time, we saw DuPont Kevlar come to market, which even today is still a leader in heat and cut protective engineered yarns. But moving along, fast forward to the 2000s, you see there, we saw the infamous ATG MaxiFlex Ultimate storm the market, which is still, one of the leading gloves today. That glove really redefined ergonomics and hand protection. And this is really when we saw a lot of the cotton and leather start to be phased out of the market for something thinner and really something that just made precision handling much easier. And from there, the innovation race was on, right? That's when the market started to see a deeper focus on coated seamless knit hand protection, protection from cuts, protection from impacts. We saw new standards that formalized impact protection. We even saw an expansion of the cut resistant levels there. It used to be up to A5. It then expanded to A9. We saw, workers needed higher cut protection levels. So now today, as we move into the present, it's really the focus is on how can a glove achieve high protection levels without limiting the performance of a worker's hand. And we'll dig deeper into that as we get along here, but there are some really cool ways that that's happening. So I think from here, I'll hand it off to Michelle. She's going to talk a little bit about coatings. Or I'm sorry, not about coatings, about the hand.
Thank you, Ben. I love this slide so much because I think I believe this firmly, when we protect our hands, we're actually protecting our entire body because we use our hands for so many things like grabbing stuff, communicating, creating things. Just right now, if you can't see me on screen, I'm actually using my hands as I speak. But here's so interesting. When we use our hands, actually, it's not the muscles in our hands that we use to grab things. It's actually the muscles in our forearms, our shoulders, and our lower back. And so when we protect our hands, we're actually protecting our entire body. Thank you, Ben. So we're going to talk about how materials
Oh,
work.
you know what? I'm sorry to interrupt, Michelle. I think we have a poll here.
Oh,
There we go. Yep, first poll.
difficult to handle small parts. We'll talk about that when we get to gauges of gloves and the thinness of the material, the denier of the yarn. That actually is one of the advancements that Ben was referring to. Higher gauges, higher cut scores, and that actually makes it better to handle for better tactile sensitivity. Get sweaty. I think that also depends on the type of polymer that you're using. I think that's on the next slide. So if you use a coating, for example, where the polymer, the coating it has strike through on the palm. So if you could turn the glove inside out and there's material on the inside, that lends itself to the worker perspiration on the palm. And then it also depends on what's in that polymer itself of what potential materials can actually come into the skin by absorption. So that could be a deeper conversation.
Yeah, it looks like we have our poll results back, and thanks for giving some insight there on the choices, Michelle. But looks like majority of the group is saying that the number one complaint they receive is that workers are saying it's difficult to handle small parts and tools, which really lines up well to what we're going to talk about here as we move along. So let's do that.
Exactly.
All right.
So, there's a lot of misnomers about the types of coatings in the market. And there are, when I say that, the type, not the types of coatings, but specifically that there are different grades of each polymer. So polyurethane, for example, has different grades of the quality of the material. Nitrile has different grades of the quality of the material, natural rubber latex as well. And then to compound the confusion, you have also different finishes. So you have a microsurface foam, smooth, crinkle, and textured. And every one of those actually respond differently to whatever the application is. So what happens is generally that people try to put a round peg into or a square peg into a round hole. They'll try to put one product across all plants in every application. However, and not with the lack of understanding that each one of these materials perform differently, especially when you factor in that there's different grades of the compound of the material itself. Now, I don't want to get too geeky in the weeds here, but there are simple ways that you can actually determine what that performance will look like. We do a thing called Coding Palooza where we work with end users to kind of show them how different materials work in different applications. And it's because of those different grades of the polymers themselves. A good example of that is I use silicone windshield wipers. And I use silicone windshield wipers knowing that they're more expensive, but I understand how the polymer or material silicone works, where it works in really high heat temperatures, up in about 600 degrees and like negative 60 degrees. So in inclement conditions, I'm not having my windows streak because I've invested in a higher grade polymer or higher grade material to prevent that, and I don't have to change them as often. So that's kind of an analogy of understand how materials work to actually benefit you.
Yeah, thanks, Michelle. And I'll just double down on that and say, we always say grip's the first line of defense, and it seems very simple to understand what a polymer might do. But to your point, they can be, there can be evolved polymers, there can be, lower grades. So it's good insight there.
Well, and I'll add one more thing, Ben. If you can't grab it, no amount of cut resistance will prevent your hand from slipping. None. It doesn't matter if you go to A9 because what comes after A9 is chain mesh. So it really does come down to the material that you're using to grab the product.
Absolutely. So moving along here, thanks, Michelle. We're going to jump into some standards here and then the materials that are used to achieve these standards, right? But I think the first thing we want to touch on is probably the most referenced standard when it comes to hand and arm protection. A lot of you guys have heard these things before, maybe not, but ANSI/ISEA 105, right? This standard is all about testing products to the level of cut resistance, the level of abrasion resistance, and level of puncture resistance. And those are all critical characteristics that help protect your workers against the risks they're facing or even the environments they're in. What we wanted to point out here, one thing that did happen last year is there was an update to this standard, and the primary focus of that update was around the icon you see on the left there. So previously, if you're a safety manager, even in the safety world, even in the manufacturing world, there were 3 separate icons that classified these testing levels, right? There was a cut icon, there was a puncture, and abrasion. Sometimes all 3 would be listed on the glove, sometimes only one. So the great thing about this update is now there is one uniform icon in that pentagon shape that helps us understand the 3 levels that one product will achieve. So again, where can you reference these things? There are a ton of documents out there, even on the PIP USA website, to understand more about the testing, how it's done, how you can read these icons, and how it simplifies our lives. But the big thing is now you should see this icon on the actual product. So you don't have to go back to data sheets to see, hey, I've got a glove that's wearing out quick. What's that abrasion level? The cut level's already on the glove. Now you're seeing all 3 in one spot, and it makes life just a lot easier for everyone. So always want to point that out. It's still the same testing methods, but a much easier process to identify those critical protection levels.
Well, we're going to talk a little bit about materials, and they're almost as confusing sometimes as coatings can be. Because while we may know some of the basics like HPPE, Dyneema, Kevlar, metal mesh, glass fiber, fiberglass, aramid blends, even graphene. How these yarns are wrapped and upwound actually impact the performance of the product. And so understanding how each of those materials and their limitations work is also crucial to selecting the right product for the application, more specifically the task. So to give you an example, Kevlar is great for terms of cut resistance, heat resistance, and flame resistance. However, it's really has very poor abrasion properties. And so there's a difference between understanding what is actually abrasion, which is the resistance of two materials, versus cut. And so sometimes we'll use the material that is actually abrasive that we should be using for abrasive, like a Dyneema material, for example, as opposed to Kevlar. Making sure that you have those right materials along with the coating impacts the performance of the product that you select. Next slide.
All right, thanks, Michelle. So there's a little bit about cut resistance. Again, kind of the same deal here with impact protection, right? So the anti-ISCA 138 standard, just a little background. When the first impact gloves came to market, there was no way to measure how effective they were at protecting against impacts. It was just, hey, there's material on the back of the glove, so you should be protected from impacts. And today, that's really where the value of this standard comes in. We have the anti-ISCA 138 standard, which came along in 2019. And what this test does is it helps us understand just how effective an impact glove is at absorbing impacts to the hand. And you might wonder, how is that? This is simply put, but really, these gloves get tested by weighted objects being dropped onto the knuckles and onto the fingers of the glove. And obviously, a testing machine does this. But from there, the testing machine measures the force that's transferred to the hand after the impact. So whatever the measurement figure is, gets classified into these three levels that you see on your screen. Level 3 is the highest protection level. So, 80% of the force being absorbed before that force is transferred to the hand. Next most effective would be level 2, being, the next highest, with 67% of the impact being absorbed before transfer to the hand. And then level 1 being the lowest, meaning 45% of the force is still going to be transferred to your hand and bones after impact. So level 1 gloves are really for light impact risks, or maybe even working in tight spaces where bumps or scrapes could occur. And then you've got 3 and 2 for high and medium. So again, it wasn't there before, but now we can now identify and much better understand the effectiveness of an impact resistant glove and how it absorbs impact energy. And that does make a difference for more heavy duty tasks when you think of oil and gas, mining, things like that. Or like I mentioned, maybe it's just light impact protection. You need maybe an MRO application where you're working in tight spaces. So again, kind of like what Michelle presented with the cut resistant materials, you can see here some of the common materials used to achieve impact resistant ratings. And again, this isn't everything out there, but these are more of the popular options. And the use of these materials are all aimed to dissipate that impact force, to limit the force transferred to the hand. You think of pads that are used by football or hockey players while they're playing, right? It's we're industrial athletes, and it's kind of the same deal. But these materials do have subtle differences. They do have subtle differences in price points. But TPR is really the most common you'll see. It's generally sewed on the back of the glove, not always, but generally sewn on the back of the glove liner. So if you're experiencing that TPR coming off or lifting from the glove liner, that usually means that the stitching has frayed or snapped, which can be an issue. Now, one material, I'm not going to go through them all, but relatively new to the safety world is D3O, which really originated in the world of tactical military protection, even in sports like BMX. So really anywhere impacts or crushes can occur. But D3O has a really unique and interesting molecular makeup, I'll say. It actually stiffens upon impact to repel that impact rather than so much absorbing. So a question we often get is, hey, why D3O other than it stiffens? And to that, I always think with D3O, you can protect with less, right? You can protect from those heavy duty impacts with less material, less bulk on that glove, which means ultimately your workers are going to experience better breathability and better dexterity. Now, obviously that differs if it's, a coated seamless knit glove versus a leather glove, but really D3O is a scientifically proven material that outperforms the rest with less. And most
Oh,
D3O, sorry, Michelle, did you have something?
yeah, I'm going to add to that, Ben. The one advantage of D3, it's also used in like motocross for lightweight protection. But the advantage of a D3O material, regardless if it's ours or others, is that it's actually a non-Newtonian material. So you could actually bounce a ball on it and it stops this ball. And so when you're talking about impact, you're actually hoping to stop the impact or crush of whatever the material is, the force that's coming to hit the hand. So when you look for impact style products, you're really looking for increased mobility as well as a level of protection, either L1, 2, or 3. And then you want to look at the profile of that product. So you can have a low profile, which increases the mobility of worker's hand on the back of the hand and still achieve an L3 impact. So really understanding how materials work is kind of the messaging that we continue to drive home, because we can all read about what a standard is. We can say that this is the level of cut we have to have. We've decided that perhaps this is the type of polymer we should use, but all of these materials impact the performance of the product and the useful life of the product itself, and then worker functionality and comfort.
Yeah, absolutely. And just to close things up there, you know, to Michelle's point, yes, the spec, you might need impact protection, but just like the cut resistant materials, just like the coatings, ultimately the glove you choose is going to depend on what are the needs of the workers past protection. Obviously, protection is very important, but what are the workers doing on a day-to-day basis? Do they need touchscreen capability? Are they handling small parts? Are they working in confined spaces? And, same thing with coatings. How about the materials they're handling? Are they hot? Are they oily? Are they wet? All these considerations are why there are 1,000 different impact resistant gloves on the market. So something as small as the pattern of the impact material can make a world of difference in dexterity and tactility and really ultimately worker compliance. So again, important to understand the materials and to learn these new technologies and be exposed to them. All right, now I think Michelle's going to jump into some trends, innovations, and misconceptions we're seeing today.
I love this product. I love talking about gauges because then we say this today. The trends in hand protection is thinner gloves, higher cut scores, which speaks to the poll questions about increasing tactile sensitivity and dexterity. So that's the best analogy that I can give you to describe all these gauges is pretty simple. A 7-gauge glove, primarily used in food processing, even 10-gauge today, 7-gauge is like a sweater. So imagine putting on a sweater on in wintertime. That's what that glove would feel like in your hand. A 10-gauge will feel like maybe like a golf shirt, something along that line. 13 and 15 gauges is like a tube sock. When you get to an 18 gauge, it's like a dress sock. 21 gauge is likened to pantyhose. So as you go up in the numbers, the higher the number, the thinner the material or the denier of the yarn. So pretty simple way, an analogy of when you look at hand protection, about 70% of the market today is a 13, 15 gauge product. So think tube sock, and then 18 gauge, think dress sock, 21 gauge, think pantyhose. So when you ask for higher, like better dexterity, tactile sensitivity, you want the thinnest denier of the yarn that you could possibly get. And then you want to look at, okay, is there things like abrasion or is it cut? Then you choose the material cording and coating based on that specific task. So 21 gauge today is probably the leading thing that we see growing the fastest, 18 and 21 gauges, because of that need for worker to pick up small parts. And so it's achieved through this. But bear in mind, when you use the analogy of a 13, 15 gauge being a tube sock, that tube sock's probably going to last longer than the 21 gauge or the pantyhose, likened to run. So you may not get the same performance in terms of the criteria, useful life of the product. And we'll talk about how you can determine those things. So I like to say that hand protection, and I will, hand protection is like life. We have to give something to gain something. But Also, I want to say this too very clearly. At PIP, we don't sell gloves. We don't make gloves. We sell hand protection, and we talk about it in terms of all of these different types of things that have an impact on why you choose what you choose, how it impacts the worker, increasing productivity, materials that matter, and then trying to get them in the simplest of terms so that the worker understands why it matters to them. That's the most important thing that we can stress is why does it matter to them? Why does it matter to you? And trying to give analogies that make it simple for you to explain to them as well.
Yeah, great points, Michelle. And the only thing I'll add to that is, we talked about misconceptions, and we know 21 gauge gloves are storming the market, and for good reason, right? You can achieve that higher cut resistance with a thinner glove, but you also do have to consider your application, right? If you're doing heavy duty abrasive work, and a longer glove life is something that you value, you do have to consider the coating of the glove and the abrasion resistance. Typically, when you have a higher abrasion level, that equates to a thicker coating. And with these 21 gauge gloves, everything has to be done in ratios to feel comfortable and achieve that tactile sensitivity. So,
Ben, if you don't mind, actually,
yes,
let me just add something here. The abrasion resistance is actually comes from two things. Comes from depends on the type of coating that you use. Mostly, it comes from the material that you choose, and the yarn and the liner itself. So, for example, if you look at Dyneema, Dyneema is 40 times more abrasion resistant than Kevlar. It doesn't mean that one is better than the other. It just means that they actually perform and they behave differently. So the thinness of the denier and the yarn itself also lends itself to a thinner coating in most cases to achieve superior tactile sensitivity when having to pick up very, very small parts.
absolutely. So important to consider the type of work really you're doing. All right.
So design and function is a really critical aspect as well. And when Ben was talking about the evolution of hand protection, I look at that first picture that he showed, and I think about it that when baby Jesus was born, he literally the wise men brought it with them, but they left it because Jesus was going to be a carpenter, not a welder. So we think about how gloves are designed. It's really critical to look at the hand and specifically like welding products. Most of the design today is what's called a 2D design, and it's flat and it's straight across the fingers. And yet, when you look at your hand, when you're using a welding glove or a leather glove, it's neither flat nor straight. And so, one of the advancements that we are doing today is creating 3D design products. So it conforms to the hand immediately. We did a study about how long it takes to break in a stick welding glove, and in most cases, it was about a 5-day period of time before the glove was trying to break in. And it was based on a thought about if you wear cowboy boots, how long does it take to break in a pair of cowboy boots? So what if we could make a product that, or develop a product with the welder in mind, or even a leather driver with the welder in mind that was actually curves and conforms to the hand? And so that's what we did. And in doing so, what was achieved was that you literally could say, what if I were to give you a product that increases your functionality, conforms to your hand, and increases productivity and better tactile sensitivity, worker comfort, all of those things. And you get it immediately because if you wanted to increase your yield, it would be achieved almost instantaneously. And so the function and the design of a product is also critical to worker acceptance and compliance. But more important, actually, that they will love it, they will wear it, and they will use it. And so, the goal is that you really want to hope that you want to give them a product that they like, that they'll wear, and gosh, that you hope that they think when I get home, I better be wearing my hand protection. So when we really think about designing products, we're thinking about the hand, because I said that that literally when we protect our hands, we're protecting our entire body. And when we think about that, we actually think about how the hand is designed itself when we develop products. The other thing is that we are the largest domestic manufacturer of cut-resistant gloves and sleeves in the United States. I'm pretty proud of it. We manufacture in Wilkesboro, North Carolina, in the beautiful Blue Ridge Mountains. If you've never been, I suggest you go. But there was a comment earlier about sleeves falling down, and there's a lot of configurations that actually can be done on a sleeve to prevent that from happening. As in other advancements in like we talk about in gauges of hand protection, the advancements in sleeves is now moving away from like 2-ply to single ply, achieving the same levels of cut and oftentimes the same levels of heat protection. So there's a lot of advancements in that area as well. And should you need help looking for that, I hope that you reach out to your safety partner and ask for some assistance.
Awesome. Thanks, Michelle. And I think we should have a second poll question that we might have ran through. So I think we can launch that now.
Do I answer these now? Let me see here.
No,
So,
that's all right, Michelle. We can I think they're just going to answer and then we can talk about
okay.
the results. All right. Looks like the majority of responses um, is basically saying workers don't often give feedback on PPE. They tend to wear whatever is provided to them, no matter the comfort or quality, which is interesting.
Yeah, I think that also comes down to the product that was chosen. And then in addition to that, how we educate workers why they use what they use. Not all things are equal. You don't use the same tool for every job. So why would you use the same type of hand protection? And so one of the things that we strive to do is to educate workers as to why materials matter to them, how things are chosen. And when we talk about useful life criteria, we actually developed a process where we ask for worker feedback. And as a result of that, we will sometimes, provide other safety equipment for them to take home so that they remember that protection doesn't stop when you end your job, that it works for you at home as well. And so there's effective ways to actually get worker feedback. And we have done that quite successfully with some of the end users that we have the privilege to work with.
All righty. So moving on here, I want to talk a little bit about heat stress, which has been a huge topic in safety these past few years, but it's really interesting because we rarely hear considerations for gloves or sleeves as an effective part of a heat stress program. But the truth is about wearing conventional gloves, those older style gloves, is that just the nature of anything on our hand will trap heat in at the hand, at the extremity. We can usually experience sweat build up over time, especially with a glove with a non-breathable coating or something that's a little thicker. And really, the wrong gloves can cause discomfort, which leads to removal, which ultimately leads to, 100% higher chance of injury. So you see some stats here in the bullets on the left side of your screen about the hand, but it is a fact, right? Our extremities are thermal regulators, and our hands and feet are leading that charge. So what can be done about this? And when you think about your heat stress program, you might think, is it worth the time and effort to address hand and arm protection? And the answer to this, with the big focus going on is absolutely. And there are a few ways to achieve cooler hands with gloves on, but it really depends on the need of your protection. And, from a cooling technology perspective, we know there's PPE out there, bandanas, towels, things like that cool us off. But there are cooling technologies out there that are embedded into gloves, infused into gloves. And Adapt, for example, is a technology that we offer. It's truly innovative. It's a micro encapsulated technology that we offer inside of select gloves that actually activates as you're moving your hands and working throughout the day. And you see the testing there. Up to 67% less hot zones can be experienced with that Adapt technology. And we actually did test this by working in 20-minute intervals an adapt glove versus a conventional polyurethane glove, and the results showed that hands did remain cooler based on those thermal imagery measurements. But really, another way uh, at looking at adopting a technology like this for your workers is, yes, these these gloves with cooling technology actually can be documented in the PPE controls section of your written heat stress program, which again is a big topic right now. Um, these technologies can support thermal regulation, which is one of those things that drive up the causes of heat stress, if not addressed. So really cool tech coming along there, and I always like to mention that it can be included in your written heat stress program. But we can't just talk gloves. What about sleeves, right? So many sleeves used today, and I think Michelle mentioned this, a lot are made with that conventional two-ply aramid, which they do a great job at protecting against cuts and heat. Um, but I'm sure many people have experienced this. Many workers roll those sleeves down during the day to cool their their arms off. Their arms get hot, right? So if this is a struggle for you, it's probably time to look for a thinner form of arm protection, just like we talked about gauge. Like Michelle mentioned, whether it's cut, whether it's heat or sparks you're protecting from, I can almost guarantee there's a single ply form of that protection out there that will keep workers cooler and more compliant. So I always like to point that out too. Protection has gotten advanced, it's evolved, it's gotten thinner, and it can make a big impact on keeping workers cooler and more compliant. And then one last trend here we want to discuss is sustainability, which right now is a topic. Um, it is something that it is being adopted. It's not the most easy to adopt for all companies. And that's because the absolute truth is oftentimes PPE made with recycled or bio-based material can come with a higher price compared to those traditional conventional materials. But it's important to know if sustainable PPE aligns with your company's overall sustainability goals, which 9 times out of 10 it does. There are some very positive impacts that these options can make to reduce your overall carbon footprint. And the best thing is, there's no sacrifice to that performance or protection you need. But to quantify those results, there has to be real data. It's about how much of the product is made from that recycled or that bio-based material, and how does that equate to CO2 emission reductions, right? It's great to say that a product is sustainable, but you always have to prove it. So whether it's comparing it to the emissions of, a traditional alternative used, with a different type of material, or if it's comparing the emissions of the material that was used to make the product that otherwise would have been thrown into the landfill. You just have to look for that data that can support that switch that aligns with your overall goals. And lastly, another thing to consider about being more sustainable with your PPE choices is, what about the type of PPE being used? It doesn't always necessarily have to be a product made from bio-based materials or recycled materials. It could be a higher quality, more durable article of PPE, something that has a longer lifespan, right? Michelle's going to jump in next here about useful life criteria, but PPE that lasts longer opposed to a cheaper upfront option does a few things. It reduces change outs, which we know that's less waste. And it's less volume of PPE entering the landfill as a result of less waste. So again, it could even save you money on the back end by purchasing less of that PPE per year if it lasts longer. So the point here is there are a few ways to make your PPE program more sustainable, whether it's by material, by durability. And before Michelle touches on useful life criteria, I think there's one last poll question we want to launch here.
And Ben, our attendees see that on the screen there. Our question is, what ANSI IC cut level is most widely used in your facility or on your job sites? And we really appreciate everyone's feedback on the polls today. And just wanted to remind everyone to please go ahead and drop your questions in. We've gotten some fantastic questions so far, but you can do that by clicking on that Q&A button at the bottom of your screen and typing in your question there. Thank you very much for the feedback today.
Right? Looks like, all right, so it looks like majority falls within that A2 to A4, but we know, cut resistant needs are evolving. So A6 to A9 is not too far behind. So um, interesting there, and kind of falls in line with what we're seeing.
Yeah, it does align with the trends. And I think I want to just say this, A9s, while they are the highest level of cut, it doesn't prevent educating your workers. And then you have to consider what happens after A9. Where do you go after A9? Because there's nothing after A9. So if those injuries still occur, the choice really today is either engineering the hazard out or chain mesh is your next option. So in my experience, I think sometimes people try to say, if I go to the highest level of cut, I'll prevent this. And there are certainly applications where that level of protection is required that is not discounted on us. However, in most applications that I have seen that are assembly, typically it is not required. It comes down to different things such as tactile sensitivity, the design of the material, how thin the glove needs to be, etc. So in those cases where you're really thinking I need to go higher and across the board, maybe consider looking at those areas that really require higher levels separately, as opposed to making a blanket assertion across the place. Because yeah, I really do have to think, what is after this? If this doesn't work, what comes after this? It's chain mesh. And to give you an idea of chain mesh, if you've ever gone to a Renaissance festival, you might have an idea what that looks like to wear. Measuring and understanding useful life criteria is really based on a question that we get asked frequently: is how long will this last? So years ago, I was working with a large end user, and the question kept popping up, and I thought maybe I ought to write a process so that people understand it. Using vending machines is great for the dispersion of items, but it doesn't really answer the question of how long does this last, because it's so common. And yet, no credible manufacturer in their right mind can tell you this, because actual conditions determine the performance of the product. We don't really dictate your culture. And so the goal is to try to help with a process so that you can do that, especially in situations where you have a leadership or purchasing or wherever that may be, that has a hard time understanding, cost per wear versus cost per pair, and how to determine cost per man hour, maybe even measuring productivities, etc. So, I thought maybe I'd kind of put something together to do this, and we do this on a regular basis with specifically some large inner users, but it's really to identify the product, to identify a test area, not to make it big across the board. You really want to try to start smaller, because it's when you start doing it in a broad mass scale, it's kind of like into taking your children down the cereal aisle and asking them to pick one. And so you really want to kind of keep it smaller, and then having a variety of folks there in that pilot group is really critical. Well, like whether it be tenure or age, or even the gender and the ethnicity is really critical, because you're going to get all these different perspectives. So trying to have a really good test group is crucial to achieving good results, or the data that you're looking to hope for. And so, sometimes like you'll get what I like to call the farmer mentality, where that person has bought $1 million combine. And so they know that they're going to take care of that thing. And then you have, and sometimes that person has been there for a while, so they've learned how to work around it. So then you have the younger person, that is just kind of getting out in the world, that's learning from those things. And so you kind of get a different perspective when you have a really good test pilot of people. And then, you want to evaluate the product, like actually put it in, you select the employees, you want to put it in there. More also, I want to back up, establishing a timeline is really critical because if you don't have a timeline of like when we'll start and finish it, you really have no data to put to support what the results are. So, you really have to kind of manage what those expectations are. Evaluating the product. I like to use a Ziploc bag myself. We use a form that has a QR code on it for people to actually give their feedback. And when they do that, we may, send them a pair of safety glasses for home or send them to the safety professional, whoever is handling that process. But we like to put them in a Ziploc bag with the glove and the date that they put them into service, and maybe the QR code that they scan. And then when they're done and take it and they're completely dead or whenever that timeline ends, you take them out of service. I like to put them in a bag and then I'll use disposable gloves and I pick them back up because you want to kind of inspect those to see which departments maybe there was some more life that could have been had. Maybe that's a level of education to say, why did you throw this away or why did you get rid of it? What did you think was wrong with this? Let me show you how this works, etc. And then once you actually collect all that data, you can actually put that together and calculate costs. You can calculate all kinds of different scenarios depending on what your objectives are. Because to me, the most important question to ask any safety professional is, what does a successful hand and arm protection program look like to you? And if you could prioritize your objectives, what are those as well? So that we're working towards your goals, not what we think they are. That's the most important thing. And then we present the findings. I guess I should have said that too. You calculate the cost, you present the findings. And that really changes it from how much did it cost per dozen or cost per pair to how much it actually cost per wear. And just developing a process makes it easier for people to understand how to do that. We also do this in our workwear.
Yes. All right. So that concludes everything we have to present today. Just want to, we did thank you in the beginning, but a double thank you for, again, your time today. Please feel free to reach out to your PIP representative, or go ahead to our website. That's www.pipusa.com for more information. And I think we are ready for some Q&A.
Excellent. Well, thank you, Ben, and thank you, Michelle, for sharing your knowledge with us today. We truly appreciate it. Before we start the Q&A, we want to let everyone know about the evaluation survey that we're asking you to complete. That survey will open in a different screen after this webinar, and your input is really important to us because it does help us to improve our future webcasts. And we just invite you again to drop any questions you have in the Q&A. We welcome any and all of those questions, and let's get to some of those. First question from our audience. Peter has a question. He asks, has there been any alignment with the ANSI and the European standard EN 388?
In some regard, yes, but in most ways, no.
Okay.
Aligning with the cut standards as they correlate to numbers is probably the closest that we're going to get in terms of the cut resistance. Like for example, if you look at an A4, that's and in Europe, they're primarily our A3s are typically the highest. A4s, I mean, are probably the highest. A3s, A4s. In the US, we use the 105 standard, so we could go a different direction, but the correlation is actually the numbers at the end of it. So if you use like a A4, the E might it might be a D after that, when you're reading what that means when you're looking for the cut scores, there's to be an E after it, so that correlates to that ANSI 105 number. And the
Excellent.
other thing is that in terms of cut, the EN uses newtons, whereas we use grams.
Okay. Excellent. We appreciate that. Elisa from our audience asks, can you tell us if there's a relationship between correct PPE and occupational diseases when evaluating the production during the production of gloves?
Not to my knowledge.
Okay. Great.
Good
Thank you for that,
question. Wow,
Elisa.
that's
Yeah,
a
thank you
great
for that.
question.
Yes,
Wow. We got to
absolutely.
save
Thank you.
that one.
I wanted to ask our next question is, what's the benefit of a lower gauge glove if 21 gauge can protect with the same cut score?
Great question too. So often it comes down to how long it will last. So I might have heard me mention that, 7 gauges are primarily used in like poultry or chicken plucking or beef processing. And so for those applications, they typically launder, and so they'll have they actually call that turns and how many laundering cycles they get out of it. So you'll get more turns if you think about it because the denier of the yarn is thicker, and so they'll last longer. Also, it depends on what they're doing, but there's even a trend in that industry that is going more towards 10 and 13 gauge products as well. But it actually has to do with the wear of the product, how long it lasts. So also correlates like when you think about the difference between a 13, 15 gauge, like that tube sock analogy, versus the
Hmm.
pantyhose. Similar correlation in terms of how long the material will last and perform.
Okay, great. And Ben, you shared the pentagon shaped logo that's new with the ANSI IC 105 standard, and a question we received was, are there any changes to abrasion, cut, and puncture resistant testing with that change?
Um, I can confirm, but to our knowledge, no, the testing remains the same. The biggest change with the updated standard is just the representation of the testing levels.
The
So again,
icons.
it's no longer the three separate icons. You'll have
Hmm.
one uniform icon with those three test ratings, available to you, and 9 times out of 10 will be on the product.
Okay,
That's a good question too, because for years we were teaching people to look for these four numbers. And so the redesign was a way to try to simplify that, which I think sometimes when that happens, it leads to more confusion. That's why it's so
certainly.
important to teach it.
Okay. We got a question in from Douglas who asks, any specific gloves you recommend for chemical uses, and are there nitrile and neoprene considered equal for most chemicals?
That is a fantastic question,
Thank you,
especially for
Douglas.
this polymer girl who started her career in coatings. Um, there is advancements that and actually you use different things. So chemical gloves depends on the chemical. Also depends if it's immersion or intermittent contact. So that matters in terms of the type of product that you use. Neoprene and nitrile are used for different things. One is so neoprene, for example, is great for acids and caustics, whereas nitrile may not is caustics, but may in acids, whereas neoprene may be used more for things such as I don't want to say this specifically, but let's just say methyl ethyl death. And so, you actually need to have someone help you with that to understand what that application looks like. And then also when you're looking at chemical testing, you want to know, if it's immersion or intermittent contact, like I said earlier, because if it's in contact, you may use a disposable product or tested. So you want to make sure you have that data as well. And we'd be happy to help you determine what that information looks like. And it's a really great question because I think we're seeing the trend come back for different chemicals now, where over the course of probably the last 10 to 15 years, the EPA has moved towards more citrus-based and type of chemicals. So yeah, that's a wonderful question.
Excellent. We thank Douglas for that. Michelle, you had mentioned, I wanted to kind of stick to the polymer angle here, and a question we had come in is, how can you assess which polymer coatings and finishes are the best for the work that you're doing? How do you start that process?
Okay, great question. Man, these are awesome. So really it comes down to like taking that product and working in the materials you're in. When I talked earlier about doing code and paloozas, like that's a thing that we do, but it's actually I take these different materials and I'll use like wood and WD-40 or all these different things and see how it responds to that kind of material. A basic thing you can do is take water and pour it over the coating and see if it foams up. That actually tells you how it might respond in your application. So that is actually when it foams up, that's surfactants on the product, specifically nitrile. And so if it's foaming up, it might be slick when they put it on. And so just doing water will kind of show you some of those things of how it performs. And then, making sure that you understand kind of the mill thickness or the thickness of the material that you use. And each one of these kind of perform differently. Like if you have a foam nitrile, that's supposed to form kind of like a sponge. If you have a microfoam, that allows for air to come in, so maybe not as good for like oily saturation. So just start with water. See how it works with water. And then go and try, see how, take a part of that, a piece of something, and see how it performs that way in with your own help. So like one of the things that I've loved doing in my career is like getting on a line and working with people. How could I talk about this if I wasn't able to figure it out with them to see for myself? Confucius said, "Tell me something I'll forget, show me something I'll remember, involve me and I will understand." That's the key to learning.
Great. Thank you for that, Michelle. We appreciate it. I wanted to add in a question we received from Bethany from our audience. And Bethany says, we're currently having an issue with hot glue sticking to the gloves that our team is using. Would you happen to have any advice on gloves that resist adhesive better?
Yeah, silicone.
Excellent.
Silicone might work for that actually, because you can peel it off. That's also something you, depending on the type of glass manufacturing, you might see with the butyl acetate monomer. So it kind of comes off and they can kind of use it. So that might be a solution there. I'm not sure, without understanding more about the type of adhesive or the glue, but silicone is typically, can be, I shouldn't say typically, I don't want to make a broad stroke here, but silicone can be used in applications such as that.
Excellent. We thank you for that. And the next question we had is Ben. I know you talked about the ANSI IC standard. We've obviously talked about the European standard, but our team just jotted down a question during the presentation. The OSHA standard on PPE is 1910.138. Are there any takeaways that can be applied to arm and hand protection from that standard as well?
Ben, would you like me to take that one?
Yeah, go ahead, Michelle. There are parallels there.
So, this is such an interesting one because the standard is so vague when it comes to hand and arm protection, right? It
Hmm.
basically what it tells you is that you have to have done an assessment. And not much has changed in that over the course of 25 years. You have to done an assessment to determine what those hazards are. And if you cannot engineer it out, you have to provide proper PPE. So vague, which I think is lends itself to the confusion around the types of materials and that you use and task specific applications, etc., because of that standard is so vague.
Great. Thank you for that. We appreciate it, Michelle. We get this question a lot from our safety and health readers, and somebody would like to know, as a one-person safety team, where do I start when it comes to implementing a hand and arm protection program, and what are my first steps?
Man, this is a great audience. Gosh, where were you guys yesterday when I was in Youngstown, Ohio? Um, I think it starts with us. It starts with you. Okay. The first thing is that, I'm a big disciple of Simon Sinek who said people don't buy what you do, they buy why you do it. So ask yourself why you're doing it. And once you believe in what you're doing, it takes one other person to believe in what you're doing also. That you show them that you care. At the end of the day, people don't want to know, they don't want to know what we know, they want to know how much we care about them. And I think that starts with that and explain why it matters to them. Like simple things like, yes, you have to have done an assessment. Work with a good safety professional. If you need help with that, with a local supplier, we'll be happy to help you there. But most importantly is teaching people about why it matters to them, like things that they may not think about. By losing a digit, for example, might prevent them from buttoning a shirt, or even playing catch with their child, or tying their shoes. The impact to them of losing an eye, bring it home to them of how it matters to them, and that protection does not stop the moment that you leave your job. It is everyday practice. I am a glover through and through, so much so that when I'm traveling, I pass out hand protection everywhere. Because I want people to know that their hands matter. Because like I said earlier, when we protect our hands, we're protecting our entire body. But more importantly, I want them to know that they matter too. That when they go home, that we care about them extending that protection when they're at home. And I think when we do that, people are more inclined to accept the fact that we are trying to protect them. It's really not about saving money for the company, although that is a portion of it, that we have their best interest in mind. And we're happy to help you find somebody who can help you do those things.
Great. Thank
Yeah,
you
and
for that.
I would just double on that to say too, sometimes it does take an army, so utilize those resources. As a safety pro, it's PPE isn't everything. There's other aspects that have to be managed for sure, but utilize resources. We have a team out there that goes out and assesses sites and lends that helping hand when it comes to PPE expertise. So find those resources and definitely leverage them.
Yeah, well said, Ben. Thank you. It looks like we have time for one more question today before we wrap up, and that question is, the impact material on the back of our gloves often peels off. What could a more durable solution be to this?
I'll take that one too, Ben. That actually has to do with how the product is made and sometimes the quality of the manufacturing process. So you can actually heat seal, you can seal them, heat seal them. That's one way to do it. You can sew them. And so it depends on how the product is made. And also we'd have to understand more about the application that could be impacting that. I don't want to make a broad stroke and say that it's a poorly manufactured product, but typically it's either heat sealed or sewn. And so those can have an impact of why that might be occurring.
Excellent. Well, folks, unfortunately, we've run out of time today. We thank you all for attending, and we'd appreciate you taking just a minute or two to share your feedback via our survey. A big thank you goes out today to our terrific presenters, Michelle Glukowski and Ben Julian, and of course, everyone from our sponsor at PIP Global Safety. This ends today's Safety and Health Magazine webcast. Thank you, everyone. Take care and have a safe day.